Okay, so digital to analog conversion and analog to digital conversion in layman's terms. We're going to start with the digital to analog conversion because you need to understand how digital to analog conversion works in order to understand how analog to digital works. So it's the obvious place to start. In order to explain digital to analog conversion, which is essentially the translation of a binary number into a variable voltage output, I'm going to start with a binary number up here on the screen. I've listed it vertically because that's going to help with the explanation, and I've put the most significant bit at the top. The other thing I'm going to do is make this look like an electronic register, which essentially it is. So we're going to add a voltage supply at the top and a 0 volts at the bottom, and we're going to separate out the bits so they look like individual circuit lines, which essentially they are. Now, if we take the most significant bit in our 8-bit byte that we've got here, obviously that has a decimal value of 128, halfway between 0 and 256 increments. If we attach a resistor to that and connect that down to another resistor that connects to 0 volts, we've essentially created a potential divider. And if we give these a value of R, for the sake of this explanation, because they've both got the same value, the voltage in the middle is half the supply voltage. So whatever the supply voltage is in between those two resistors would be half of that. We'd connect that to a buffer, which is our output, so that whatever happens with the output, any load on the output, doesn't affect the voltages that are going on with our resistors. So I'm going to mark this up at the top there as our V divided by 2. So if this bit is on, it has an electrical value of V, and if it's a 0 or off, it has an electrical value of 0. So if that most significant bit is set, then it will apply the voltage to those resistors and we will get half the voltage out of the output. Now, if we do the same with the next bit down, only instead of having a value of R, it has twice the resistance of R. So it'll only let half the amount of current flow, half the amount of electricity through. So we'll still have a potential divider, except now it'll only be adding a quarter of V to our output. And we continue this all the way down the bits in our byte, our output byte if you like, all the way to the bottom, and multiply up the resistors as we go. So as we go to less significant bits in our byte, the amount of voltage that is added to our output is halved each time. So you should be able to see from that whatever number you put in the binary register will pretty instantaneously translate to the relevant voltage on the output, and that can be anywhere from 0 volts up to V, whatever the supply voltage is. So that, in a very quick layman's terms, is how digital to analog conversion operates. Okay, so now we know how we get from a binary number to a variable voltage on a pin on a microprocessor or whatever the digital to analog converter is. So how do we get from an analog voltage back to a binary number? Well, I'm going to pop a diagram up on the screen here, and in that diagram you'll see that at the top there we've got our analog input. So that's the analog input that we want to measure, and that analog input goes into a comparator. What we've also got here at the bottom of the diagram is we've got an up counter, so it's a binary counter that will count from 0 all the way up to FF, and that's connected into a digital to analog converter. So all the time that binary number is counting up as the input to the digital to analog converter, the output of the digital to analog converter will be climbing from 0 to V, the supply voltage. Now, depending on what level the analog input is at some point the output of the digital to analog converter is going to go past that. When it does, the output of the comparator will change, which will cause the clock enable for the counter to stop. And that is also our trigger to read the up counter for a binary value that equates to the analog level. Now typically within an analog to digital conversion, you'd do this conversion several times because there'll be noise on the signals and things like that, and you'll take the average of the result. How many samples you take to get that average will depend on how fast your output is expected to move and how much noise you're aware is on that signal. So you can tune analog to digital conversion depending on the specific signals that you're trying to measure. But that is how analog to digital works. You use a digital to analog converter and you compare the output of that to your analog input to find the binary value that corresponds to the analog input value. And that's it. It's as simple as that. Digital to analog conversion and analog to digital conversion, converting from a binary number to an analog voltage or from an analog voltage to a binary number, is pretty straightforward, really. That's it for now. See you soon.